Let's do spanning tree protocol. IEEE 802.1D standard. This is what called as classical spanning tree. The classical spanning tree protocol is a timer based protocol, meaning it's slow, and not only that, only one instance of STP for all VLANs. These are the two things that you should know about the classical spanning tree protocol. Only one instance of STP, meaning if I have 10 VLANs, how many STP? Only one. If there is only one STP, then you cannot do load sharing manually. And switches never support automatic load sharing. If you have multiple instances of spanning tree, then you may set some priority and say these VLANs will go via the upper path. Priority is small. And these VLANs will go via the down path. Priority is small for these VLANs. So by doing so, you can have some sort of load sharing, manual load sharing. But the classical spanning tree won't support that because there is only one instance for all VLANs. So Cisco came up with this spanning tree. You can call it as per VLAN spanning tree plus. That's how the word per VLAN got added to the spanning tree, and then the plus got added. This per VLAN means this plus, and per VLAN is same. So for every VLAN, you got a separate instance of STP. STP per VLAN. So when you have STP per VLAN, and when we got multiple paths to reach some nodes in layer 2, VLAN 10, VLAN 20, VLAN 10, VLAN 20, VLAN 10, VLAN 20, VLAN 10, VLAN 20. So when we have multiple VLANs, we can go here and say for VLAN 10 priority is 0. Here for VLAN 20 the priority is 0. And for VLAN 20 the priority is 4096. For VLAN 10 priority is 4096. So smaller the priority, more preference is given to become a root switch. So the switch on the top, let me name it as switch 2, becomes the root switch for VLAN 10, and switch 3 becomes the root switch for VLAN 20. If this is a root switch for VLAN 10, then block will be somewhere opposite for VLAN 10. If this is a root switch for VLAN 20, then there will be a block somewhere opposite. So all VLAN 20 will go via the below path, and all VLAN 10 traffics will go via the upper path. You cannot call it as load balancing because it's not equal load balanced. Depends on how much of traffic goes on VLAN 10 and VLAN 20. If VLAN 10 comes, it will use the upper path. VLAN 10 traffic may be less traffic than VLAN 20, but VLAN 20 cannot go on the upper path because there's a block, green dot there. So VLAN 20 can go only via the bottom path. So this is the best advantage of per VLAN spanning tree. We can have load sharing. Whereas in the first one, the classical spanning tree, you don't have more than one instance. So for all VLANs, one path will be blocked, the other path will be available. Now, these both are timer based, meaning if a link goes down, to decide that link has gone down, it will take 20 seconds. Let me repeat. When a link is gone down, to decide that link has gone down, so I need to do some recalculation. To take the decision, I need to do a recalculation. See, when a link is down, everyone will know immediately the link is down. Line protocols will go down, so switches will know that the link is down. I'm not talking about that part. For STP to uh, take initiative, it will wait for 20 seconds. After 20 seconds only, STP will say, okay, I'm not hearing BPDU from so and so for 20 seconds. So let us now recalculate. So they now try to recalculate, you know how the blocking port will be going to a listening state to see the current topology status. It will go to the listening state. And in the listening state, it will wait for 15 seconds. 15 seconds in the listening state. And then it will go into another state called learning state, after which it becomes forwarding. See, to remove the blocking to listening, to remove the blocking and put it into a listening mode, it takes 20 seconds. And then 15 seconds it will wait in listening state. And another 15 seconds in learning state. Then only the blocking port becomes forwarding. Let's say, for example, here, for VLAN 20, there's a block here. VLAN 10, as usual, it goes this way. VLAN 20, it was going this way, but there is a break in the cable somewhere here. So, because there's a cable break, it needs to now go via the upper path. How long it takes? See, for deciding to take a decision to unblock this block, this green color, to remove that green color, it takes decision only after 20 seconds of waiting. The switch will wait for 20 seconds, hoping that at any time this link may come and I'll get the BPDU. It's hoping, but it is not going to come because there's a break and no one is there to rectify it immediately. So after 20 seconds of waiting, this block will be called as listening state. BLK will change into listening, alternate 15 seconds. And then it goes to learning. See, VLAN 10 is so far no problem. VLAN 10 is still going on. VLAN 10 member is happily pinging. There is no disturbance caused to VLAN 10. It's only 20 now getting dropped. 20 packets are coming, but they're getting dropped. 15 seconds of learning. Then it switches to forward. So totally how much you got is 50 seconds of 50 seconds of convergence. Now again, when this link comes back, it will fall back. For that, you know very well when the link comes back, for the line protocol to come, it will take some time and 20 seconds is wasted. After which only the BPDUs will go, and this will go to blocking, and this will again be the listening and learning and forwarding. So the timer based 20 seconds of waiting to take a decision, 15 seconds of waiting in listening state, 15 seconds of learning. This is not good for a large environment. No one will agree this downtime. It's too much. 50 seconds of convergence time is too much. The impact is going to be very bad. So came next version of STP called rapid, which is opposite to what we saw now. This is slow in convergence. When you rectify the delay, it becomes another version, which is IEEE 802.1W. 1D is the classical spanning tree. 1W, and then came IEEE 802.1S. So 1W is rapid. So this rapid spanning tree IEEE 802.1W, rapid STP, is modified version in Cisco. So rapid spanning tree means RSTP, PVSTP. Yeah. So in Cisco routers, it is per VLAN and rapid. Understand? Actually, as per the standard IEEE 802.1W, it is not per VLAN. It's only one rapid spanning tree. See, there's a big advantage with Cisco. Others don't have. Others do have it, but you need to enable it manually. I have seen other vendors do support per VLAN rapid spanning tree. But when you enable rapid spanning tree in Cisco, by default, it is for every single VLAN a separate rapid spanning tree, a separate fast spanning tree. But other vendors, when you build rapid spanning tree, there will be only one instance of rapid spanning tree for all VLANs. But you can go and enable them more if you want, and it becomes IEEE 802.1S, which is MSTP. That is the difference. The other vendors, you have rapid spanning tree, only one instance. And when you go and say, no, I want 5 instance, then it becomes IEEE not 2.1s, which is MST. You need to enable MST for that. But in Cisco, when you say rapid spanning tree, actually it is Cisco's rapid spanning tree gets enabled. It is as per the IEEE 802.1w standard. Right, so rapid spanning tree is fast because it is not timer based. It is not timer based. It won't be learning the topology every time. Only first time initially, this topology will be learned by every switch using BPDU, and every switch will remember that there is a block in this place. If something goes wrong, I need to unblock. Every switch will know it. So when something goes wrong with this link, immediately they unblock. There is no again learning. They listen and they found that there is a link failure, there is a BPDU failure. Immediately, as soon as the BPDU fails from this link, from the switch on this link, this will tell the second switch to unblock, and it will immediately unblock. Not a timer based, immediate. That's why it is faster. So convergence is very fast in rapid spanning tree. Now when there is a speed, there is more energy taken, more CPU utilized. Fast means more consumption of fuel. Same here. When it is fast, definitely CPU utilization is going to be high. And now if I have 100 VLAN, then 100 times I'm increasing the speed of the CPU when I enable rapid spanning tree. So there came another IEEE 802.1s, which is for multiple VLAN, you will give an instance. Instead of every VLAN one instance of spanning tree, you're going to give spanning tree one spanning tree for multiple instance. Sorry, multiple VLANs. You're going to give one STP for multiple VLANs. You can decide how many STPs you want for your topology. Now, so now what we need to understand here is, so MST allows you to decide how many instances we are going to run. For example, here we have 100 VLANs on all the switches. I said I want 2 instances of MST. Instance 1 will will be responsible for VLAN 1 to 50. Instance 2 will be responsible for VLAN 51 to 100. In this case, there's only two VLANs. Sorry, two STPs. So I can go here and say for instance 1, priority 0. And instance 2, priority 4096. See, I cannot say priority 100, 50 and all. 0 after that 4096. It will be increment of 4096. Why? I'll tell you a bit later. Give me a few minutes, finish this, and then we'll discuss that. And now, in switch 3, for instance 1, priority 4096. For instance 2, priority 0. Which means VLAN 51 to 100 will be going this path. And VLAN 1 to 50 will be going the upper path. In this way, you can reduce the number of reduce the consumption of CPU. When you reduce the number of instances, CPU utilization gets reduced. Not only that, if one of the switch don't support MST, they will fall back to per VLAN spanning tree. All will fall back to per VLAN spanning tree. If any one switch don't support MST, the other three will fall back to per VLAN spanning tree. So there is backward compatibility. You need to do the configuration on every single switch. MST that you configure, the mapping that you do with the instance and the VLAN numbers need to be repeated again on all switches. There should be a match in configuration. If there is any small conflict in configuration, then they will fall back to per VLAN spanning tree. If you have VTP version 3, you can enable MST configuration replication. We need to enable it. By default, they are not. You need to ask VTP to replicate MST configuration to all switches. Yeah. So, any question on what I have spoken so far? We explained all the difference between these four STPs. Do you have any question? Hmm. 1W is rapid, 1S is MST. 1S is MST. And then 1D is classical. This is Cisco. This is Cisco. Modified version of classical is what? Per VLAN spanning tree plus. Even this is also Cisco rapid spanning tree per VLAN spanning tree plus. But we still claim to be IEEE because it is actually it follows the same rule. Only the difference is in IEEE it not ruled at 1W. Only one instance. Whereas Cisco's rapid spanning tree is per VLAN spanning tree. All right. Any other question? Okay. Why the increment of priority is 4096? You see the number of bits given for a bridge ID is 16. For a bridge ID, the number of bits given is 16 for the bridge ID. So if you take bridge ID, what all included? In a bridge ID, VLAN number, VLAN ID, and then MAC address, and then priority. All this together, three together, is what we call it as bridge ID. VLAN ID, MAC address, priority. All these three together, we call it as bridge ID. So, which one comes first? Priority comes first. On the 16 bit, out of 16 bit, the higher order 4 bit, which is 2 to the power of 15, 14, 13, 2 to the power of 12. These are the 4 bits that are given for bridge ID. And then comes the VLAN number. VLAN number is from 2 to the power of 0 to 2 to the power of 11. That is why the maximum number of VLAN that you can create is 4096 in a switch. Why? You see, you have only up to this much. 2 to the power of 12 is 4096. This is 1. This is 208. What is 2 to the power of 11? 2048. Correct. And then 1026 to the power of 10. Keep adding all this, you will get 4095. Yeah, 4095. So that's why up to this much is what we have for VLANs. That's why the biggest VLAN is 4096 when you start from VLAN number 1. Here you are starting from 0. That is why it's shown as 5, but it's actually 6. So the higher order 4 bit, if all the 4 bits are 0, what is the priority? 0. And what is the next possibility? 0001, which means 4096. When I put this, it becomes 8192, which is 00. Yeah, this is the one. 10. It's increment of 4096 because it is this, from this bit only it is given for priority. So it will increment by 2 to the power of 12. By default, what is the priority on all switches? 32768. Why, you know? By default, only this bit is on, all the rest are 0. Only this bit is on. So which is 2 to the power of 15 to the power of 15 is 3 to 768. That's why the default priority is 3 to 768. If you are changing the priority, this is how you have to change. You need to either put 0 or 4096 or 8192. Increment of 4096. That's the option. There is no other option. Next. So this, in this bridge ID, first comes VLAN ID and priority. If there is a tie in that, then only the tail end point is MAC address. So these two are together, 16-bit. MAC address is separate, 48-bit. If there is tie in the first portion, the tiebreaker is the tail portion of the bridge ID, which is the MAC address. MAC address is 14-bit size. Do you have any question?